Okay students, so now this is page 101 and this is example 9.1, but this time we're going to do it using the critical value method. So we already calculated the difference in the before and after scores, and we found the sample difference mean and the sample difference standard deviation already. Now we want to write a test hypothesis, and they asked us in the question, does counseling help reduce anxiety? So H naught will be mu sub d for the differences equals 0, meaning there is no difference. And HA will be mu sub d less than 0, meaning a reduction in anxiety. Find a critical value for this problem. We need a t with alpha being 0.01 and n minus 1 degrees of freedom, so that's 9 minus 1 degrees of freedom, and it is, by this sign, a left-tailed test. Now if you get out your t-table, and you know it's a one-tail area, 0.01, and you move down to 8 degrees of freedom, you get 2.896. And if we want to go ahead and draw our rejection region, this is a left-tailed test, so the critical value is negative because it's on the left-hand side of 0. Again, because it's a left-tailed test by this sign here. So here's my rejection region. To find the test statistic, we need a t equals d bar minus 0 all over standard deviation of the differences divided by the square root of n. So d bar was 33.33 minus 0 all over 22.92 divided by the square root of 9. Make sure that you watch your calculations by assigning parentheses where appropriate. You should be getting a test statistic of 4.363. Now this is a positive test statistic, so it does not fall in the rejection region. Therefore, in our next to last step, we're going to fail to reject H naught. And our conclusion would be, let me move this one over. Based on the evidence, there is not a significant, not so much a difference, but a reduction in anxiety after counseling at alpha equals 0.01. So that is the critical value method for doing dependent sampling, otherwise known as a before and after study. And that was example 9.1.